Welcome back to the deep dive. I have to admit, I've been vibrating with this weird mix of excitement and honestly intimidation all week for this one.
Oh, I get that.
We are tackling a giant today, and I really don't use that word lightly. We are diving into the mind of a man who was described by the Nobel Committee as a rebellious teller of the truth. A man whose work was compared to Isaac Newton's in terms of its sheer, tectonic impact on human knowledge. We are talking about Bertrand Russell.
It is a genuine pleasure to be here,
Yeah.
and I completely understand the intimidation factor. Russell is a titan. He really is.
He's everywhere.
He is one of those rare figures in history who, didn't just stay in one lane. He managed to span logic, mathematics, social criticism, political activism, and philosophy. Somehow he was just brilliant at all of them.
Right.
But what makes this specific deep dive special, and maybe a little more accessible, is that we aren't just looking at his technical logic or his heavy mathematics.
The really dense stuff.
The Principia Mathematica stuff, which frankly can be impenetrable even for specialists.
Oh, thank goodness for that. I opened one of his logic books once, and it looked like alien hieroglyphics to me.
You and me both, absolutely. Now, today we're looking at a specific moment in his intellectual journey. We are focusing on his 1927 book, which is simply titled Philosophy.
Right.
And we are framing it through the lens of the Nobel Prize he won much later, in 1950.
And that actually brings me to the first real surprise I had while prepping for this. I always, I categorize Russell as a mathematician or a logician, or maybe, a peace activist, given his later years protesting nuclear weapons. But he won the Nobel Prize in literature. That just threw me.
It throws a lot of people. But it is such a crucial distinction, and it really tells you everything you need to know about the man.
Okay.
When the Swedish Academy presented him with the award, they explicitly stated it wasn't just for his technical achievements. It was because he addressed his books to a public of laymen.
So for people like us.
For everyone. They honored him as a brilliant champion of humanity and free thought. The permanent secretary of the Academy actually compared him to a character in a George Bernard Shaw comedy.
Yeah.
Outspoken, cheerful, always throwing out bold retorts.
I love that image. I really do. It changes him from this dusty academic into, a bit of a rock star.
That is exactly right.
Yeah.
He was a public intellectual in the truest sense of the word. He wanted to talk to everybody.
That sets the stage perfectly, then. It tells us that he's not writing this book, Philosophy, for other professors who are locked away in ivory towers. He's writing this for us. He wants to engage the general public.
Yes.
So before we get into the nitty-gritty of atoms and psychology and all that, what was Russell's mission with this specific book? What is he trying to do to the reader?
He is trying to fundamentally change your attitude toward knowledge itself. That's the goal. In the source material, Russell defines philosophy in this very specific, almost humble way.
Okay.
He says philosophy isn't about having a set of ready-made answers. It isn't a catechism where you just memorize the truth.
It's not a rule book.
Not at all. It is a method. It is a way of handling knowledge.
A method to handle knowledge. I like that phrasing. It sounds practical. But handle it how? What is wrong with how I handle knowledge right now?
Well, according to Russell, quite a bit, actually.
Oh, we're great.
He aims to cure us of what he calls the 3 defects of common sense knowledge. He says that what passes for knowledge in ordinary life is usually cocksure, vague, and self-contradictory.
Ouch. Cocksure, vague, and self-contradictory. I feel a little called out there.
I think we all should. It's a diagnosis of the human condition.
I think we can all relate to being cocksure, being absolutely certain about things we probably have no right to be certain about. It feels like the default setting of the internet age, actually.
It is the default setting of the human mind. It's a survival mechanism, right? You have to act decisively. But Russell argues that the philosopher, or anyone thinking philosophically, must possess a very difficult combination of traits.
Which are?
A strong desire to know, combined with a great caution in believing.
Huh. That seems like a really hard tension to maintain. If you want to know something really badly, don't you tend to just jump at the first answer that looks good?
That is exactly the trap. That's the cocksureness. The urge to have an answer, any answer, makes us accept things that are vague or even contradictory just to settle our minds. We want the world to make sense now.
Right. We want certainty.
And Russell wants to dismantle that comfort. He wants to take the world we think we know, the world of, solid tables, distinct people, clear causes and effects, and show us that it is actually a construction. He wants to dismantle our naive realism.
Naive realism. Okay, let's define that before we move on. That's the belief that the world is exactly as we see it, right? I see a brown table, so there is a brown table. I see a person, so there is a person. Simple.
Correct. It is the belief that our senses are clear, transparent windows onto reality. The belief that things just are what they appear to be.
And he's going to tell us they're not.
And over the next hour, we are going to follow Russell as he tears that belief apart using physics, behaviorism, and psychology, and then attempts to put it all back together in a way that is scientifically sound. Yeah. It is quite a journey.
Okay, let's start the demolition then. Russell begins this deep dive by looking at human beings. But he doesn't start with our thoughts or our feelings or our complex inner lives. He starts from the outside.
Yes. And this is part one of our discussion, what Russell calls the man from without. He adopts the perspective of a behaviorist. He says, let's look at a human being strictly as a physical mechanism.
An object.
Pretty much. The same way a scientist might look at a rat or a stone or a star. No special status.
So we are stripping away the soul or the mind for a moment. We are just looking at the machinery.
Exactly. He wants to see how far we can get by just observing the physical inputs and the physical outputs.
Yeah.
And Russell breaks down any human event, let's say, reacting to the start of a race, into 4 distinct stages. And this breakdown is absolutely crucial for understanding how he reclassifies what knowledge actually is.
Okay, let's unpack this race example. I'm at the track, I see the runners, the gun goes off, and I shout, "They're off." What is happening there objectively, from the outside?
Okay, so Russell maps it out like a chain reaction. Stage 1 is the physical event. This is entirely external to you.
Right.
Light waves travel from the runners, or sound waves travel from the starting pistol through the air to your body. That is pure physics. It's just energy moving through space.
So far, nothing human has happened, just waves moving around.
Exactly. Stage 2 is the physiological event. The light hits your retina, an electrical signal travels through the optic nerve, and it reaches the brain. Or the sound hits the eardrum and goes through the bones in your ear. This is biology, but it's still, mechanical. It's a signal traveling down a wire.
Okay, so we're still just talking about biology and physics. No magic yet.
No magic. Stage 3 is the brain event. Some internal processing happens, incredibly complex chemical, electrical activity in the cortex. The signal gets routed, processed, and a decision, if we can even call it that from the outside, is made.
And that leads to?
And finally, stage 4 is the muscular event. A signal travels out from the brain to your larynx, your throat, your tongue, and you shout, "They're off."
That seems straightforward enough. Stimulus, processing, response. But Russell says this change in perspective changes how we define knowledge. Why? How?
Because from this purely external perspective, knowing isn't some mystical state of mind. It isn't a light bulb going on in your soul where you suddenly grasp the truth.
Yeah.
It is simply a manner of reacting to the environment.
A manner of reacting. So knowledge is just a fancy reflex.
In a way. Think about a thermometer.
Okay.
If it is hot, the mercury rises. If it is cold, it falls. In a very limited mechanical sense, Russell argues that a thermometer knows the temperature, or a compass knows where north is. It reacts consistently and correctly to the stimulus.
That's a strange way to think about it. So if I shout, "They're off," when the race starts, I'm just a very, very complicated thermometer.
From the strict behaviorist perspective, yes. Your knowledge is defined by your sensitivity to the stimulus and the accuracy of your reaction. If the race hadn't started and you shouted, "They're off," you would be like a broken thermometer. You would be wrong.
Right.
But there is no magic knowing, independent of that physical reaction. Knowledge is displayed in behavior. It isn't something you have. It's something you do.
That is a little humbling. I like to think my knowledge is this deep internal library of facts, not just a tendency to shout at racehorses or, answer trivia questions.
It definitely takes the ego down a notch.
But humans are obviously more complex than thermometers. I mean, we learn things. We change our behavior based on experience. A thermometer doesn't learn. If I put a thermometer in the oven 100 times, it behaves the same way the 100th time as it did the first time.
Good point.
So how does Russell explain learning if we are just machines?
This is where it gets really interesting and where Russell dives into the cutting-edge science of his time. He discusses the experiments of Dr. John B. Watson, who was the father of behaviorism, and the famous work he did with rats in mazes.
Right. I remember reading about this in Psych 101, the rat and the cheese. It's a classic image.
It is. The setup is simple. You put a rat in a maze. There's food at the end. At first, the rat just wanders around randomly. It bumps into walls. It goes down dead ends. It sniffs the floor. It takes I don't know, maybe 40 minutes to find the food by sheer chance.
Just trial and error?
Pure trial and error. But you do again and again. And eventually, the rat runs straight to the food in 6 seconds.
Oh, okay.
Now, here's the philosophical question. Does the rat know the way?
Well, yeah. I mean, it went straight there. It learned the route. I'd say it knows the way.
But Russell points out that for the behaviorist, knowledge is only that change in behavior. It is the elimination of useless movements. It isn't that the rat has a little mental map in its head, or at least we can't prove that from the outside. We have no access to that.
Right. We can't ask it.
All we can observe is that the rat's body has been conditioned to run a specific path. The knowledge is in the muscles, in the habit.
Okay, so that's the rat. It suggests learning is just repetition, just drill. But Russell contrasts this with some experiments done on apes, right? This was the part that made me laugh out loud.
It's wonderful, isn't it?
He talks about the difference between American and German science in a way that felt very, well, very Russell.
It's a wonderful bit of wit, and it highlights his personality perfectly. He notes that the animals observed by American scientists like Watson's rats, they rush about frantically, they display hustle and pep, and eventually succeed by chance.
The American dream. Hustle until you make it. Just keep moving, and eventually you'll hit the jackpot.
Exactly. It reflects the culture of the observer.
Right.
But then he says the animals observed by German scientists, specifically the apes studied by Wolfgang Köhler, behave very differently. They sit still, they think, and then they evolve the solution out of their inner consciousness.
That is hilarious. The national stereotypes extending all the way down to the animals. The Americans are frantic. The Germans are contemplative.
It is funny, but it makes a really serious point. The rat represents learning by drill, or habit. The ape represents insight.
Okay, tell me about the ape experiment. This was Sultan, right?
Yes, Sultan the chimpanzee. And the problem was different from a maze. There was a banana outside the cage, just out of reach. Sultan had 2 bamboo sticks inside the cage, but neither one was long enough on its own to reach the banana.
So he can't just run around and hustle his way to the banana. He has to use tools. He has to solve a problem.
Right. No amount of running helps. He tried reaching with one stick and failed. He tried the other, failed. Then he sat down. He didn't run around. He just played with the sticks. And then, suddenly, he fitted the thinner stick into the hollow end of the thicker stick, making one long stick. Immediately, he used it to pull the banana in.
That feels completely different than the rat. The rat gets faster gradually. The ape got it in a flash. It was an aha moment.
Exactly. And this really challenges the strict behaviorist view that all learning is just repetition and habit. It suggests that there is something like insight or a sudden restructuring of the problem. This sitting and thinking suggests an internal process that Watson's behaviorism might miss.
So what does Russell do with that? Does he just throw out behaviorism?
No, and this is what makes him so good. He's a synthesizer. He tries to bring these 2 ideas together. He argues that even this insight ultimately relies on the mechanism of habit and association.
How so? How is fitting 2 sticks together a habit if he's never done it before?
Well, Russell leans on what he calls the law of association. This is a fundamental mechanic for him. The idea is, if 2 stimuli happen together often enough, the first one eventually calls out the reaction belonging to the second.
Like Pavlov's dog. Bell rings, dog salivates.
Precisely. Or his example, a child fearing a flame. If a child touches a flame and gets burned, the sight of the flame, that's stimulus A, is associated with the pain, stimulus B. After that, the sight of the flame alone causes the withdrawal reaction. That is a learned reaction.
Okay.
So as Sultan, he's played with sticks before. He's probably seen things fit into other things. The insight is a complex combination of all these previous habits and associations firing in a new way.
So even our most complex creative beliefs are just built on this biological habit.
He thinks so. And he applies it to something really fundamental, induction, our belief that the future will resemble the past.
Like the sun will rise tomorrow because it always has.
Exactly. Russell argues this isn't a logical certainty, it is a biological habit.
Wait, unpack that for me. You mean knowing that the sun will rise tomorrow isn't logic? I thought that was the definition of logic.
It's an expectation born of habit. And Russell uses a fairly dark, famous example here to illustrate why this habit isn't the same thing as truth. He talks about a chicken.
The chicken, okay.
The chicken sees the farmer every single morning, and every morning the farmer comes and brings food.
Okay. It's a happy chicken. It's got a good life.
So the chicken has a very strong inductive belief. Farmer equals food. It works every single day. It is confirmed by observation. The data is solid. The chicken is a good scientist from its perspective.
I think I know where this is going.
Until the one day the farmer comes to wring its neck.
Right.
The chicken's knowledge was just a habit that worked until the one day it catastrophically didn't. Russell is saying our scientific knowledge is essentially the same. It is a biological expectation based on past experience. It is useful, it helps us survive, but it is not guaranteed logical truth.
That is deeply unsettling. We are just sophisticated chickens hoping the farmer brings food again. It really undermines that cocksure attitude he warned us about in the intro.
That's the whole point. And this extends to language, too. This is a fascinating part of the text for me. Russell wants to demystify meaning. He says words aren't these ghostly mental things.
What are they then?
They are bodily habits.
Bodily habits, like
Yeah.
like riding a bike or tying your shoes.
Very similar. Think about how a child learns the word bottle. It's pure association. The child sees the object, hears the sound bottle, and gets the milk. See? Here. Get. Over and over.
Yeah. Okay.
Eventually, just the sound bottle triggers the reaction of looking for the milk. To understand a word from this perspective just means acting correctly when you hear it.
So if I say pass the salt and you pass the salt, you understand. It doesn't matter what's happening in your mind. The proof is in the action.
Exactly. But Russell, being Russell, spots a problem with the strict behaviorist view on language. He finds the hole in the theory. He calls it the paradox of narrative.
Oh, this was the train ride example, right? This was great.
Yes. So if memory is just a verbal habit, just repeating words we have learned, how can we describe a new event? Watson would say memory is just laryngeal habits, kind of like reciting a poem you memorized.
A recording.
Right. But Russell says, imagine you took a train ride this morning. You might describe it with a sentence you have literally never spoken before in your life.
Like, I sat next to a man wearing a purple hat who was eating a tuna sandwich while reading a magazine about lizards. I've definitely never said that sentence.
Exactly. So it cannot be a simple habit like a rat running a maze. You aren't repeating a sequence you've learned by rote. You were using words to describe an image or a meaning.
Ah, okay.
So Russell concludes that we remember meanings and images, not just word sequences. Language is a tool we use to express those nonverbal images.
So he is pushing back against the idea that we are just machines. He's saying there is something happening inside images, meanings that strict behaviorism misses.
He is finding the balance. He's saying, yes, we are machines, but we're machines with an internal life that deals in images and meanings, not just reflex arcs. He respects the behaviorist view for its objectivity, for its scientific rigor, but he acknowledges its limits when it comes to the richness of human experience.
So the takeaway is, don't be cocksure that we are just machines, but also don't be cocksure that we are magical souls.
The truth is somewhere in the messy middle.
Okay, so that is the man from without. We are biological mechanisms learning through habit and association, but with this capacity for insight and image-based memory. Now, Russell shifts gears completely. He takes us from biology to physics. Part 2 is the physical world.
And this is where the ground really starts to fall out from under our feet. Because if behaviorism questioned our mind, physics questions our matter.
I love this section. He starts by attacking solid matter. I mean, common sense tells me this desk is solid, it is hard, it is there. If I punch it, my hand hurts. It feels undeniable.
In physics, even the physicists of the 1920s says your common sense is wrong, or at least radically incomplete. Russell explains that the table is actually a vast collection of events, mostly empty space, with electric charges rushing about at incredible speeds.
It is the shift from the old billiard ball atom to the modern atom.
Correct. The old view, the view of Newton and Dalton, was that atoms were these little hard lumps of stuff, permanent, solid, indestructible, tiny, tiny billiard balls.
Right.
But Russell guides us through the Rutherford and Bohr models of the atom, which were the cutting-edge science of his day. And he highlights something very, very strange: the quantum jump.
Nature does make jumps. That was the quote that stuck with me.
Yes. In the Bohr model, an electron moves from one orbit around the nucleus to another. But here's the kicker. It doesn't pass through the space in between.
Wait, say that again?
It is here in one orbit, and then it's there in another. It disappears from one orbit and reappears in the other instantaneously.
That sounds like magic. How can something move without crossing the space? That violates everything I think I know about moving.
To common sense, it is impossible. But the math, the observations, they demand it. And this completely changes what matter is. Russell argues that matter has become ghostly. We don't know what an electron is in itself. We only know it comes out of it, the radiation it emits, the energy.
He used the phrase ghostly material. It's like we are trying to describe a ghost by the rattling chains we hear, but we can never, ever see the ghost itself.
That is a perfect analogy. We know the structure of the atom, the math, the behavior, but the stuff, the actual substance of it, has dissolved into abstract energy and probability. And because of this, Russell argues we have to give up another cherished common sense idea.
Force.
Force. Like gravity. Gravity feels pretty real when I drop my phone on my face in bed.
Of course. And we tend to think of gravity as the Earth pulling the moon, or pulling your phone, like a person pulling on a rope.
But that's an anthropomorphic idea. We derive it from the feeling of our own muscles. When we move things, we push or pull. So we assume the universe must be pushing and pulling too.
So the Earth isn't pulling us down right now.
According to Einstein's general relativity, which Russell is explaining here, no, planets aren't being pulled. They are simply following the easiest path through the structure of space-time.
The easiest path.
Think of it like this. Imagine a stretched-out rubber sheet. If you put a heavy bowling ball in the middle, it creates a big dimple, a curve.
Right.
Now, if you roll a little marble nearby, it won't go in a straight line. It will curve and circle around the bowling ball, following the curve in the sheet.
It'll look like it's orbiting.
Exactly. The bowling ball isn't pulling the marble. The marble is just following the easiest path, the geodesic and the curved geometry of the sheet.
So the sun is the bowling ball and the Earth is the marble.
And there's no force required. It is just laziness, cosmic laziness.
So matter is ghostly energy, and force is just geometry. That really strips the universe of its solidity, its thingness.
And it gets even deeper. Russell then discusses relativity and the abolition of what he calls cosmic time.
This is the part that always breaks my brain. There is no universal now.
It is so difficult to grasp because our lives are so local. We assume that now is the same for everyone in the universe. If I snap my fingers, I assume that that moment, that now, applies to a person on Mars and a person in the Andromeda galaxy simultaneously.
But it doesn't?
It doesn't. Russell explains that if two events are far apart, the order in which they happen can depend on the observer.
So I might see event A happen before event B, but someone else moving at a different speed might see B happen before A.
Exactly. And the mind-bending part is, both of you are right. There is no single God's eye view of the timeline that can say who is correct.
So when is the order definite?
The order is definite only if a light signal can travel between the events. If event A can cause event B, then A must come before B for everyone. But if they're too far apart for light to connect them, their order is ambiguous. And this leads Russell to a very profound conclusion. The world is not made of things. It is made of events.
Events, not things. What does that mean for me? Am I a thing? I feel like a thing. I feel like a noun.
Not to a physicist. To a physicist, a person or a table or a star is just a string of events connected by causal laws. Think of a tune.
Okay.
A tune isn't a single object you can hold in your hand. It is a sequence of notes played over time. It has a structure, a continuity, but it isn't a static lump. It's a process.
Okay, I like that.
Russell suggests you are like a tune. You are a sequence of events, physical and mental, connected by causal laws. You are a history, a process, not a static object.
That is surprisingly poetic for a book about physics. I am a tune played by the universe.
It is beautiful, but it also serves his main purpose. It dissolves the hardness and thingness of reality. If matter is just events and energy, and if time is relative, then the solid world of common sense is an illusion. The chair you're sitting on isn't a solid object. It's a slow-motion event. It's a swarm of quantum activity that just happens to be stable enough for you to sit on for a while.
Okay, so we have dissolved the mind into habits, and we have dissolved matter into events. Now we have to connect them. Part 3 is the problem of perception. This feels like the bridge.
It is the bridge, but it is a bridge that leads to a very, very strange place. This is where Russell tries to answer the question. If the world is just these abstract physical events, how do we see it? How do we bridge the massive gap between an electron and the sensation of blue?
Right, because I do see a world. I see colors, I hear sounds. I don't experience events in space-time. I experience a blue sky.
And this leads to what Russell calls the causal chain of vision. He asks us to just trace the path. Let's say you see a star.
Okay, I'm outside at night. I'm looking at a star.
Step 1. An event happens at the star. Atoms radiate energy, photons are released. This happened, by the way, maybe millions of years ago.
Right, the light has been traveling for a long time.
Step 2. Those light waves travel across the vacuum of space. That's a series of events happening over years. Step 3. The light finally hits your eye. Step 4. The optic nerve fires, another series of bioelectric events. Step 5. Something happens in your brain.
And then I see the star.
But where is the seeing happening? Where is the image of the star located?
Well, a star is in the sky. It's out there.
Is it? The physical event you are actually experiencing, the sensation of brightness and light, is happening at the very end of that long causal chain. It is happening in your brain.
Wait, so the star that I see is in my head.
Precisely. This is the paradox of location. Naive realism says you see the star out there, but physics says the sensation, the experience itself, is a physical event inside your own skull. When you look at the night sky, you are, in a very real sense, looking at the inside of your own brain. The star you experience is a percept, a mental image, caused by the physical star, but located in you.
That is deeply claustrophobic. It implies we never actually leave our heads. We are walking around inside a little movie theater in our own cortex, watching a film about the universe.
It gets worse, or better, depending on how you look at it. Russell introduces the physiologist paradox to really drive this home.
Oh, lay this one on me.
Okay, imagine a physiologist is observing another man's brain. Maybe he has the skull open in surgery or he's using some advanced imaging device. He thinks, I am looking at this man's brain.
Right. He is looking right at it. He's seeing the gray matter. He's seeing the neurons firing.
But just apply the causal chain again. Light has to travel from that man's brain to the physiologist's eye through his optic nerve and to his own brain. So what the physiologist is actually experiencing is a percept inside his own head.
So he isn't looking at the other brain. He is looking at a picture of the other brain that has been constructed inside his own brain.
Exactly. We are trapped in our own private perceptual worlds. And to clarify this, Russell distinguishes between private space and public space.
Your buzz down for us.
Private space is your perceptual field. It is everything you are aware of right now. It is what you see, what you hear, what you feel. It has up, down, depth. But it's entirely yours. If you have a headache, that pain is in your private space. The visual image of the star is in your private space. No one else can ever enter that space.
And public space.
That is the abstract theoretical construct of physics. That is where the electrons and protons and the actual physical stars theoretically reside. We never experience public space directly. We construct it. We infer it.
So public space is like the map, and private space is the territory we actually live in.
That's a good way to put it. But we build the map based on correlations in our private territory. We learn that a certain visual shape in our private space corresponds to a hard sensation when we touch it, which is also in our private space. So we assume there is a single thing out there in public space that causes both sensations.
But the thing itself, the actual thing in public space.
We never touch it. We never see it. We only know it by the postcards it sends to our brain.
We only ever touch and see our own reactions to the world. That is a lonely thought.
It is. But it is the necessary conclusion if you take physics seriously.
This connects all the way back to the beginning, doesn't it? To the man from without. Russell started by ignoring the mind completely. And now he seems to be saying the mind, or at least our private perception, is the only thing we actually have direct access to.
That is the pivot, the grand reversal. And that brings us to part 4, the man from within. After dismantling the mind with behaviorism and dismantling matter with physics, Russell argues that we must return to introspection. We have no other choice.
This is the showdown, Descartes versus Watson.
It is the battle for the starting point of all knowledge. You have Descartes, the 17th century philosopher who doubted everything, the world, his body, God, until he hit bedrock. I think, therefore I am. He couldn't doubt his own thoughts. He started from the inside.
Right.
And then you have Watson, the modern behaviorist, who says thought doesn't even exist. It is just laryngeal movements, subvocal speech. He says we should never trust introspection because it's not scientific or objective.
So who wins?
Russell steps in as the referee. And he critiques behaviorism on a fundamental level. He points out that Watson claims to be objective. Watson says, I observe the rat. But what is Watson's data? What is he actually doing?
He's watching the rat run the maze.
But watching is a private percept. It is an image in Watson's head. If Watson denies the validity of private perception, if he says introspection and private experience are unscientific garbage, then he loses the evidence for the existence of the rat.
Whoa, that's brilliant. So if you throw out the inner eye, you blind yourself to the outer world too.
You saw off the very branch you were sitting on. Russell argues that if we reject the validity of private perception, we lose the evidence for physics itself. All of science is an inference built upon these private subjective data points. The scientist's observation is just as subjective as the poet's dream, at least in its raw form.
He uses the toothache argument here, which I found very, very relatable.
It's a classic, perfect example. A dentist looks into your mouth. He sees a cavity on the x-ray. He infers, this patient has a toothache. That is external knowledge. It is derivative. It relies on a theory that cavities cause pain.
But I know I have a toothache. I don't need an x-ray.
You know it directly, immediately. Your knowledge of your own pain is of a higher order of certainty than the dentist's knowledge. The dentist could be wrong. Maybe the nerve is dead and the pain is from your jaw. But you can't be wrong about feeling the pain. If you feel it, it's there in your private world.
And it's the same with dreams, right?
Same thing. You know you have dreams. A behaviorist looking at you while you sleep might see your eyes moving or your throat twitching. He can hypothesize laryngeal movements. But he can't know the dream. You can.
So Russell concludes that we must admit that we know our own percepts most directly. Colors, sounds, feelings, these are the bedrock. Everything else, atoms, tables, stars, other people's brains, is a theory we build to explain the patterns in those colors and sounds.
Yes, and this leads to a somewhat startling conclusion about the validity of physics.
Startling how?
Well, physics aims to be objective truth. But if all our knowledge starts with our private percepts, and those percepts depend on our eyes, our nerves, our brains, then all our knowledge of the physical world is, in his words, infected with subjectivity.
Infected, that is such a strong word.
It is, but it's appropriate. If you are colorblind, your data about the world is different, and so your physics would be different. If you are on drugs or just tired, your perceptions change. The instrument is part of the measurement.
So what can we know for sure about the outside world?
Russell says we can know the structure of the physical world, the mathematical laws, the causal patterns, but we cannot know the intrinsic quality of it.
We know the tune, like we said before, but we don't know what the instrument it's played on actually sounds like.
That's a great way to put it. We know the mathematical relations. We know that A causes B, but we don't know what A is in itself. We only know its effects on us.
But he makes a guess, doesn't he? A speculation.
He does. And this is where it gets really interesting and a little wild.
Okay.
He says the only part of the physical world we ever get to know from the inside is our own brain. When we experience a thought or a sensation, that is a physical event in the brain, but we are experiencing it from the inside out.
Okay, I'm with you.
So he speculates, maybe the stuff of the rest of the world isn't dead, hard, mindless matter. Maybe it is stuff that resembles our own mental events. Maybe the universe is made of the same stuff as our thoughts, just arranged differently.
Whoa, so atoms might not be tiny rocks. They might be tiny proto-thoughts or proto-experiences.
He doesn't go quite that far into full-blown panpsychism, but he suggests that the absolute division between mind and matter is an artificial one we've created. He's suggesting that if the only part of the universe we know from the inside feels like mind, it's not unreasonable to guess the rest of the universe might be made of something similar.
And that leads us to the grand finale.
It leads us to the outro and his final synthesis, neutral monism.
Neutral monism. Okay, break that down for us. It sounds technical, but I feel like we are on the verge of the big picture here.
It is the idea that mind and matter are not two different opposing substances. They're not oil and water, not ghost and machine. They are different ways of organizing the same neutral stuff.
And what is the stuff?
Events. It always comes back to events.
Events.
Remember, the world is a stream of events. If you group those events one way, by their causal laws in public space-time, you get physics. You get a star.
Okay.
If you group those same events another way, by how they are experienced together inside one biography, one person's perspective, you get psychology. You get seeing a star.
So the star and my seeing of the star are part of the same underlying fabric. They're not two different worlds.
Exactly. Russell says, matter is a logical construction of events. Mind is a cross-section of those same events. He gives an analogy. Think of a directory of names. You can arrange them alphabetically, that's one kind of order.
Right.
Or you can arrange them geographically by city, that's another order.
Yeah.
It's the same names, just a different sorting method.
Hmm.
Mind and matter are two different ways of sorting the same fundamental events.
So the world isn't solid rocks with ghostly spirits floating around inside them. It is just happening. It is a stream of events.
The stream of events. Physics describes the mathematical laws of the stream. Psychology describes the events themselves as we experience them from a particular vantage point. They are two different maps of the same territory.
So what does this all mean at the end of the day? We started with a Nobel Prize winner telling us not to be cocksure. We tore apart the human body into a machine. We dissolved this table into empty space. We realized we are trapped inside our own heads. And now we find out that mind and matter are just two sides of the same coin.
It means that the world is far richer, far more complex, and far more mysterious than our common sense would have us believe. It means that science doesn't explain away the mystery. It deepens it. Russell is asking us to live with that uncertainty, to accept that our common sense view is just a convenient fiction, a useful biological tool.
It really does. I feel like I'm going to look at my coffee table differently now. And myself. I'm not just a person looking at a table. I'm a series of events interacting with another series of events in a vast cosmic stream.
And that is the goal of philosophy. Not to give you a neat answer, but to change how you see the question.
Before we go, I want to leave the listener with one final thought, something to chew on.
I have one. It's the logical conclusion of everything we've talked about.
Let's hear it.
We talked about how physics says the physical world is mostly empty space and abstract mathematical equations.
Right.
And we talked about how psychology and physiology say our experience is private and internal, a construction inside our brains. If both of those things are true, then the world we think we live in, this common sense world of solid tables, blue skies, and objective reality out there, is actually a dream.
A dream.
A collective dream. Or a private one. It is a dream that happens to correspond sufficiently with the underlying reality to keep us alive. We interpret the abstract mathematical signals of the universe into a movie that makes sense to our primate brains. But it is our movie. The universe itself is something else entirely.
It is a dream that keeps us alive. That is both beautiful and terrifying.
It is, Russell.
Thank you for guiding us through this. This was a true deep dive.
My pleasure. It was a lot of fun.
And to our listeners, keep questioning the table. We'll see you next time.